Hey, it's Dan Melnick. I'm the CEO and co-founder of Zing, and I'm proud to be a sponsor of this podcast. So please check us out today as we can help fuel your business growth. myzing.io. Thank you.
I'm great. Thank you very much, Dragan, for giving me opportunity to interview you for my channel.
That's perfectly okay. I'm very happy to be here.
So I've gone through your profile. I can see you're doing multiple works. So I thought to tell about your work to my audience.
Okay, that would be good. I'm very happy to talk about that. I'm very excited about what I do and what I'm engaged with.
So before that, can you please introduce yourself to my audience?
Okay, my name is Dragan Savic, and my background is in water engineering, and I've been a consultant, I've been an academic, and I've been a leader. I'm currently the CEO at KWR Water Research Institute in the Netherlands. I'm very passionate about water and science and how water affects sustainability, and also how we as research organization and individuals can contribute to a more sustainable world.
So you're from?
Sorry?
You're from Netherlands.
No, I'm originally from Serbia, but I moved around quite a bit. I did my PhD after graduating from undergraduate degree and then doing Masters of Science in Civil Engineering and Water. I moved to Canada and did my PhD there, where I also stayed afterwards and worked as a consultant. And I moved to the UK, where I became a professor of hydroinformatics. I stayed there for 25 years. And now, since 2018, I'm in the Netherlands as the CEO of this research institute.
So what is your company is about?
Well, the company is a research institute that is owned by drinking water utilities of the Netherlands and from Flanders. And it provides research and science input into the practice of drinking water systems in the Netherlands and Flanders. So basically supports innovation, development, and efficiency drive by these water utilities, which are publicly oriented water utilities.
So you have been in this role from?
Since July of 2018.
So how is it working in this role?
It's wonderful. We are an organization that is non-for-profit, so we don't pay any dividends to our shareholders. So everything that we earn, we put into research and innovation. We support these organizations who financially obviously support us. As I said, 200 people, about 130, 140 researchers. We employ researchers from all over the world. We employ 38 researchers from, I would imagine, about 30 countries. And we provide the highest quality research to all our clients. We work both nationally and internationally.
So what is the research is about?
Okay. So, primarily we focus on drinking water supply, sources, treatment, distribution, but we acknowledge that drinking water systems are part of a much wider water cycle, total water cycle, where you have from sources to wastewater treatment and then again to water sources. So our research covers everything in that water cycle from, as I said, from basic water treatment and different water sources, groundwater, surface water, and unconventional water sources, rainwater, desalination, brackish water, and also then treatment, various ways of treating different quality water in order to be of highest possible quality and biological stability in the distribution system. So that's ensured also by the work that we do. And in the Netherlands, unlike in many other countries, we don't use chlorination. There is no need to use chlorine in the distribution network to make the water of highest quality and not allow microbiological problem in the delivered water to the customer. So that's one side of things, and then we are obviously involved in planning how these assets are going to be maintained over many years, because these systems have to last anything between 50, 100 plus years. They don't get replaced very often. So it is very important how to plan where to invest and where is most important and where is the best to invest in order to keep them. But also it is important to understand what the customers, what are the users of water thinking about the service, about the costs, about the quality of the service. So we do that type of research, looking into also resilience of these systems. So quite a varied areas of research. My background is hydroinformatics. It's basically about how can we address the challenges, global water challenges and global water security. And when I say water security, I really mean various dimensions. You know, water supply is only one dimension of that, because then if you have a drought, how are you going to ensure supply? But on the other hand, we have floods. So when you have too much water, you need to deal with it, protect people and their properties, and commercial world and public from the flooding. Then, you know, if you have transboundary waters, there is a possibility of collaboration, but also possibility of conflict over the water rights. Then if you think about landslides, they're caused by instabilities in soil caused by water, desertification, pollution. Again, we are losing access to clean water because we pollute more and more of water, and pollute it with chemicals and other compounds. And that's, again, part of our research here. So hydroinformatics, what I do is like a management philosophy to address all of those global security challenges, which is made possible by ICT technology. So I'm looking into application of artificial intelligence, application, transformation through digitalization and so on, and how that can bring more efficiency to the utilities, but also bring us closer to sustainability, because through satellites, through remote sensing, through collection of more and more data, we can have better idea of water resources in the world, of the quality, of the quantity, and how best to utilize them.
And water is the very major thing and essential thing for any species on the planet. You working on it globally, how is it, and what information that you have got in all your experience that studying all the planet?
Well, United Nations have come up with Sustainable Development Goals, SDGs, and SDG 6 is related to provision of drinking water and sanitation for the population. And I'm sad to say, but we are not very close to meeting all those sustainability goals, particularly SDG 6, because quite a lot of other SDGs, like eliminated poverty and, smart cities and, livable cities, they all depend on water. If you don't have water, you cannot have livable cities, and you cannot have eradication of poor, poor people, they are all kind of affected by pollution, by flooding more than other parts of the population. So my view is we are kind of moving in the direction of meeting those goals, and those are ambitious goals, but we are not succeeding in meeting them. And that's why I think there is urgency of trying to meet those goals. And that's why I also think that this digitalization can also help, because through that we can have a global observatory of what is happening with water. We collect quite a lot of data, but now they're in silos. They may be in silos of different countries, so countries not sharing publicly the information, but also even within a single country, even within single water utility, you may have kind of walls between data of one part of the company and the other company. A good example is companies that have water and wastewater, like water and sewage. Water business is kind of one, and then wastewater business is another, and there is not always this link in terms of exchanging data and understanding how can, for example, certain methodologies be applied from one area to the other.
And what is your objective with KWR?
In KWR, we are trying to help all our clients meet the sustainability goals and also meet their own goals in providing sufficient quality water for various purposes. When I say sufficient quality water for purposes, I mean for drinking water quality, the highest possible quality and required quantity for the public. But when I'm talking about commercial use, industrial use, they may not require the same quality. So we invest less, different type of treatment, cheaper treatment, still satisfying their needs. So it's what they call horses for courses. You have to have a portfolio of solutions, not all of the same quality and quantity. For example, water being used in industrial processes, it may not require drinking water quality.
And how many of experts are working in KWR?
So we are an organization with about 200 people in total, but those who are experts, as you call them, who are researchers working in various fields of water planning and management, is between 130 and 140. So quite a substantial number. So we deliver, over 100 projects per year dealing with various aspects of water management.
So your geological location is Netherlands. KWR work for Netherlands.
Yes, KWR is based in Netherlands and serves mainly all Dutch water companies, drinking water companies, plus a company from Flanders, from Belgium, which is the city of Brussels. So these 11 companies, they decided to put their investment together into our institute, in our company, so that we can support them with providing required research for them to deliver highest quality water and required quantity to their customers.
You have done PhD and you have been consultant and you have been a professor. So studying water for a long time in your career, how is that and how is that contributing to your present role today?
I think it is very important to have experienced different types of work related to water. As you just said, in my native Serbia, I had particular consultancy position, which we worked with mostly dams and reservoirs and how they impact and how they provide storage for water. And then when I moved to Canada, I started working on the artificial intelligence and applications in the water sector, and then moving and then I worked as a consultant there as well, which was very interesting because we're talking about the impact of the water on the environment as well, and what those dams do to the bio world and biohabitat. And then I moved to the UK, and I moved towards more infrastructure, towards pipe networks, water distribution networks, towards wastewater networks, then flooding and so on. And now in the Netherlands, I'm overseeing much wider kind of area of research, because all these 140 researchers are working in various areas. As I mentioned to you, one group is hydroinformatics, another one is wastewater treatment and reuse of water. Another group is working on the geohydrology. Another is working on eco-hydrology and what's happening with our eco world in ecosystems in our environment. Another group is working on the boundaries between water and energy, how water impacts energy and how energy impacts water delivery. Then we have social scientists and scientists that are looking into human behavior, because we're all trying to reduce the consumption of water to make it more sustainable. How do we persuade people? What is the required level of service that they or what is the price, the cost of this? For example, water has a huge value. You just mentioned when we were starting, you mentioned how it is important for life. We can survive few more days without food, but without water, we cannot survive, really. And that's one side of the thing. And on the other side, people think that the cost of water is too high. For example, if a pint of beer or half a liter of beer is 3-5 euros, depending where you go to restaurant or you go somewhere else, 1,000 liters of water delivered to your house 24 hours, 7 days per week cost less than that. But if you ask people, they will say, oh, water is very expensive, because they feel that water comes from the skies, nothing happens to it. You had a big funnel and it comes to your house with nothing happening. But they don't know, or they forget that there is a huge kind of production, manufacturing process of abstracting water. Usually you have to pump, so energy is required. Then you treat, chemicals, energy again. You need to build these big structures that are containing water while you are treating water. Then the pipe system to bring the water to your house, they're huge. They're much more longer than transport networks, than roads. But people don't take that into account because they're underground, and they say, oh, out of sight, out of mind, you see. And then you have to do something with the wastewater that is collected from your house, from the industry, from other places, in order to be able to release it in the environment in the state that is not going to adversely affect that environment. So you don't want to cause pollution or kill fish or any other impact on the adverse impact on the environment.
So this blue planet is filled with 70% of water, and also called as water planet. So interacting with global experts in your experience, and collecting data using digital network and artificial intelligence, what you have understood, and what what uh, what is the research that you have done?
First of all, you are correct to say that huge percentage of the surface of Earth is covered by water. But when we talk about water, fresh water available for drinking or for supply, we're talking a percentage less than 1% is readily available, because only 2.5–3% is not salty water, is not ocean water. And then the rest of it, most of it, is ice, mountains, and then groundwater and fresh water is very small, less than 1%. So don't forget that. That's very important. In terms of the research that we do in using artificial intelligence, we do everything from data to developing models that help us better predict the behavior of these systems, to optimization models that improve the operations, to long-term planning and decision making or decision support. So in order to get to a decision what to do with these very costly systems, I mentioned to you, we're talking about several hundreds of thousands of kilometers of pipes within one small country like the Netherlands. So how do you prioritize where to invest? You need to make decisions. So we're using artificial intelligence for the modeling, but I'll go back to the data. Data is collected. That's part of the hydroinformatics as well, of the research. How do we trust the data? Can we improve the quality? Because usually when you speak to practitioners in the water sector, they would say, oh, data is not very good, because we work in the harsh environments, for example, in sewers or outside. If you have collection of data, there are errors. There are errors because of the errors in the sensors. There are errors in communication, so you don't receive the data part of the time. So you have some time series that has empty spaces, and then you get errors, spikes or drops. So we make sure with some kind of automated system, because it's very difficult to give it to a person and say, you correct the data. That's what we did in the past. But now, with the amount of data that's been produced today, 98% was produced in the last 2 years. That's how exponentially the amount of data is growing. So, with that growth of number of points that you have to some kind of automated system to assess the quality of the data, to do the validation, to maybe replace some of those erroneous data points in order, that's the first step, to be able to use some of the artificial intelligence then to create those models that help you make better decisions. And then we go into modeling. And in the past, for example, we use what we call deterministic model. Deterministic in a sense that we thought, because we are doing this for the future, future condition of the system, planning for the future, we assume that we know the future 100%. So we would use that prediction of the future, develop a model, and then predict how our system is going to behave. When do we need to replace it? What is the risk? And so on. Now, with these new tools, we are thinking about, or we have developed tools that are giving us probabilistic future predictions. So we get a range of potential solutions to assess the risk on the future. And then we also develop optimization model that tells us, those are prescriptive model rather than predictive, to tell us what decisions to make, what is the best decision out of all the possible. So that's the area that we are working in. So we try to reduce the pressure on individuals rather than individuals have to do all the donkey work. We are now doing it automatically. But it is very important that human is still in the loop. We don't want full automation where the human doesn't have input in the whole process. And that's, I think, one of the key contribution of hydroinformaticians or people who do hydroinformatics is that we do not totally rely just on technology. So in our case, in my view, is that the AI will not replace people, because you will still need the people in the field, you will still need the people to go and do things, but the skills of people will change. So they will need to be trained to use AI. And my argument here is that with AI, we will have to do more training than without it. And people often forget that. They think, oh, AI will come and it will replace this or that, and we will be, yes, the life will be easier, but you need to be trained to use it. And the very example of ChatGPT, everybody's now experimented with it.
So how you are using technology, products and services for your project, which is KWR?
Can you repeat the question, please? I didn't quite understand.
How you are able to use technology, products and services for KWR project?
Well, quite a lot of our projects use various different technologies, not just ICT or, computing technologies. As I said, we had various experts in hydrology, ecosystem services, groundwater, energy, water treatment, and so on. So the technology is used extensively within our organizations to improve the processes, to improve the decision making within the water sector. But as I said, we also have social scientists here who are helping us to have that human dimension of managing water. What is, for example, what is the governance structure that best supports decision making? Is the governance structure appropriate? How can we strategically influence the water cycle? Or can we look long term into the future and imagine different futures? And that is very crucial because with climate change, with population changes, with more people moving into cities and urbanization, we are going into the future that nobody can for sure say how it is going to look. So we have to look into alternative futures, and one of my projects is using that research in order to see how do we design these long-term systems, but also considering short-term variability or differences. 1 year is drought year, the next year is very wet. So how do you manage, how do you take that into account? And we use it by developing potential scenarios for the future, and then find a solution that is most flexible, that will satisfy most, or that can be adapted, so deep adaptation, because we're talking about deep uncertainty that we cannot put probability to it. You can do probability forecast for, seconds, minutes, hours, days, weeks, maybe for a year. But beyond that, we're talking about less probability, more scenarios.
And what industries are involved in this project?
Yes, and the water industry is involved in this particular project that I just mentioned. I have 3 other partners from international partners. So this is funded by European Research Council, and it's called a synergy grant because we're looking into synergies between various partners. I have three other partners in addition to KWR and myself and the University of Exeter that I also am associated with. We have University of Bielefeld in Germany with Professor Barbara Hammer, who is a specialist in machine learning, artificial intelligence. We also have Professor Marios Policarpou from University of Cyprus, Chios Excellence Center. They're experts in operational analysis, the operations of systems, water systems in this case, and also artificial intelligence. And then I have another partner from Athens, from Greece. She's an environmental economist, and bringing that human side of things into this analysis. So with the four of us, we cover both engineering, artificial intelligence, environmental economics, and rational or irrational decision making, or trying to make it more rational when humans are involved.
And you have been in this from long time. So what is the difference that you are observing in the world, the constant change that happened in over the years?
Well, if you think the global situation, where in the past and still people talk about water wars, that water can be kind of inducing conflicts between various countries. I'm looking at it from a very different perspective. I look at it as also opportunity for collaboration and cooperation. And by sharing the benefits, for example, upstream countries developing dams and reservoirs and hydropower and water supply, they can also help downstream countries to reduce flooding. It may that they want to share some electricity generated there because they stopped some water going and being used immediately by downstream countries. So kind of balanced cooperation can also bring a lot of benefits to both of the countries, much more than individual benefits. That's one thing. I mean, this transition to and transformation into digital management of water is huge. It's happening all over the world at various stages of this development. Even within the single country, you would say utilities at various stages. But the point is that we want to make more informed decision, and that is based on data. So data-driven decisions are much more rational, much more defendable, and much more efficient in terms of cost. So that's where we are going. And also, I think looking into pollution of water is very, very important, because through industrialization around the world, we are coming up with innovations of new kind of processes, new compounds, new products. And in that sense, we forget about what those chemicals do to our water. A good example is what they call PFAS, or these compounds, forever chemicals, as they call them, which are potentially toxic. You see the production of that hasn't stopped. We realize they may be toxic. We realize they are being produced for over 50 years, but we haven't stopped them at the source. What is that then doing to our environment and the water that we are ingesting and the food that is being grown on that water? So for me, cooperation, collaboration, very important, both on the local scale and on the global scale. Digital transformation, again, important. And also protection of our environment, protection of our water from pollution, microplastics, PFAS, PFAS, all of those are the key issues, but three that I really focus on: cooperation, digitalization, and protection from these compounds of emerging concern.
What are your future plans with KWR?
Well, KWR is here to stay to support Dutch and Flemish water industry, but also internationally. We've been successful in acquiring European projects and getting involved to inform the policy in Europe about water and on the international arena. So we would like to stay focused on what we're good at, and that's drinking water, but we have to kind of go wider in terms of coverage and recognition for this excellent organization, high quality research output organization.
So how you want to expand, and what are your plans if you expand?
I'm not saying we're going to expand and grow as an organization. What I'm saying is we're focusing on impact. And that impact has been very strong here in the Netherlands, but we could help others have the same impact around the world. And that's where we see our research going, showing what we have achieved in the Netherlands and in Flanders, and then use that to help others around the world come up with similar level of efficiency. In this country, the leakage is still about 5 to 6%, which is kind of world leading.
Do you have a message to world leaders who will be watching and listening to this?
Well, the message is please value water, because it's very important for our health. It's very important for economy of our countries. Don't pollute it, and trust the experts in the water field, because they work for you, for all of us, rather than for a particular organization. We all feel very strongly about what we do. Is it a research, or is it work in the practice? We're all with one key goal, is to keep water supply and you protected from water wherever you are in the world.
So where people can find you and your work in the internet?
They can find it on the KWR Water Research Institute site, which is kwrwater.nl, Netherlands. And, if you do a basic search for KWR Water or Dragan Savic or anything like that, you will find the links necessary to get in touch with us.
I'll share those links in the description, also in the screen, also in my website as well. People who finds our video anywhere in the internet can able to see the work that you're doing, can able to learn from you and can collaborate with you.
Thank you, Sai, and thank you for the opportunity to talk to you and your listeners.
And as a leader, as a scientist, and as a team lead, what is your observation about my work? Have you seen any videos of mine on YouTube?
Well, I've seen few in preparations for this meeting, and I think spreading the word about various activities, various positive activities, sustainability, efficiency in general is something that we need to do more. And obviously some people are better at doing the way you're doing it. And, some people can say that we researchers and scientists are not very good at, projecting or talking about what we do beyond our own circles. So this is something very positive in terms of popularizing or making it accessible to wider audience. I salute you on that.
And I did masters in software engineering, also bachelors in computer science and engineering. Right now, I'm working as a cloud DevOps engineer and a software engineer for a UK company remotely from India. So That's my full-time role. Apart from that, I'm interviewing experts like you around the world, more than 100 countries experts. I have interviewed more than 750 interviews I took in last 3 years. So as an observer, how this experience of communicating with different leaders around the world and engineers, architects, all kind of educated people, me trying to explore what they are doing and trying to put what they have experienced and how they are solving problems, putting it on one platform and letting the world know what they are doing and how they are making things possible. How this is going to be helpful for the viewers and the listeners and also for me.
Well, as I said, bring this closer to listeners and experts closer to your listeners is one big step, because quite often experts talk to other experts or talk within the same field, whereas you have much varied audiences here, and that helps spreading the word and also, getting more understanding of some of the expertise that I may have or my colleagues may have.
Can I put this video on my YouTube channel with your permission?
Yeah, no problem at all.
Also, can I put this audio and video clip on my podcast, website, internet, social media, everywhere with your permission?
That's good. Tag me in and I will retweet it or repost it. Yeah.
So definitely, I want KWR to reach everywhere in the world, and I hope the impact that you are expecting with this and the thoughts that you want to implement and help the humanity to save water and to use it efficiently and effectively, and also to give the same water to the further generations that you are expecting, and the bigger plans that you have. I want that to happen. uh, you know, my message through this podcast, may be helpful to you.
Thank you. That's really appreciated.
Thank you, sir, again for your time, and keep going.
Okay. Bye-bye. Sai.
Bye. Bye.